The first one we're going to do is the angle is going to be in degrees. So I want y'all to know that the hand trick that we always do works also for degrees. So I'm going to draw a hand like I normally do. But instead of labeling it with radians, we're going to label it with degrees. So 0 radians, how many degrees is that? 0. What about pi over 6? How many degrees? 30 degrees. Pi over 4? 45 degrees. Pi over 3? 60. And pi over 2? 90. Now, I like teaching you guys the hand trick with radians just because it's harder to remember with radians. Once you get to degrees, if you just think about that, the way the quadrants work. Whoa, that's a really straight line. Okay. The way we normally label these, it makes sense that 0 degrees is pointing to the right, 90 degrees is pointing up, and then the others kind of go in order. That looks kind of like a 45-degree angle right there. So your hand works just like the angles do. When you're talking about degrees, it's easier to kind of visualize. All right, so we're going to do the same thing that we've been doing, but now we're going to use degrees. All right, so this is lesson 5.4b. We're still talking about the sum and difference formulas. All right, and then for our first example, it's going to be a really long example. We're going to find the exact values of sine, cosine, and tangent of 75 degrees. Now with radians, most of the time you'll be given the fractions that add together to give you the angle in radians. In degrees, it's a lot easier to do, so you can figure these out on your own. So using the special angles in addition or subtraction, how can I end up with 75 degrees? Yeah, 30 plus 45 degrees. So 75 degrees is 30 degrees plus 45 degrees. So that's what we're going to use for our U and V today for 75 degrees. All right, so when we start off finding the sine of 75 degrees, I'm going to rewrite it as the sine of 30 degrees plus 45 degrees. So then whenever I use my formula, for U, I'm going to put in 30 degrees, and for V, I'm going to put in 45 degrees. So you guys do that on your own. Go ahead, decide which one to use, and then put in 30 degrees for U and 45 degrees for V. And then just like yesterday, we're going to use the hand trick to figure out the sine and cosine of 30 and 45 degrees. We just have to think of the angles in terms of degrees. So when we go to find the sine of 30 degrees, we use the 30-degree finger, and then it's going to be the square root of the bottom over 2. So what do y'all think? 1/2. All right, so you guys do the rest of those on your own. And we're going to end up with answer very, very similar to what we did yesterday because the same fractions were multiplying and adding. So you'll see that some kind of combination of square root of 2, square root of 6, and then 4 in the denominator. All right, I'm going to have you guys do cosine completely by yourself. You can do it. So you're finding the cosine of 30 degrees plus 45 degrees. All right, any questions on that one? Okay. The last one we're going to do is tangent. And tangent isn't any more difficult to do, like just a tangent at 30 degrees, tangent at 45 degrees. But simplifying that fraction down definitely is challenging. All right, so we'll use the tangent of a sum formula. And then when we do the hand trick for tangent, we're going to do the square root of the bottom over the square root of the top, which for 30 degrees would give us 1 over the square root of 3. which is the square root of 3 over 3. Right. What about the tangent of 45 degrees? Just 1. Good. All right, and then in the denominator, we've already found both of those, so we don't have to do it again. We just plug them in. Okay, so we have the same problems that we had yesterday. So we have this fraction inside of a fraction. We have two fractions inside of a fraction. So what are we going to multiply by? 3. All right, and now we have a radical in denominator. So we're going to multiply by the conjugate of the denominator. And for the numerator, we do all the distributing. So we'll distribute the square root of 3. And then distribute the 3. All right, and then in the denominator, we can do the shortcut distributing. This should look super familiar. And then combine our like terms. And we're going to reduce. All right, any questions on that? Okay, our last example is different. Like, we're still going to use the same formulas, but it's the setup of it is going to be different. We're not going to have special angles. So it's just going to be slightly different. All right, so our directions on example 2 are to find the exact value of the trig expression given that sine of u equals -7/25, cosine of v is -4/5, and both u and v are in quadrant 3. Okay, so those are our directions. And then it's going to tell us what to find. But right now, I'm going to draw both of these triangles. So these are two separate triangles. One triangle for u and one triangle for v. They are both in quadrant 3, so I can do the quadrant 3 for u. And then do a separate quadrant 3 for v. Okay, so what we know is the sine of u is -7/25. So what does that tell you about the opposite leg? What is 7, and the hypotenuse is 25. What about the adjacent? Anybody know it? It is a Pythagorean triple. Okay, it's 24. Now I know like most of you, are taking the ACT in a couple of weeks, and knowing some Pythagorean triples can like save you some time. This is one that would be helpful if you knew, but if you don't know it, we all know how to do the Pythagorean theorem. So we would say that whatever side we're looking for squared is equal to the hypotenuse squared minus the other leg squared. All right, and then 625 minus 49 is 576, and then the square root of 576 is 24. All right, you guys label the second triangle. I know you know that Pythagorean triple. Oh, on V, we know that the cosine of V is -4/5. So use that to figure out the sides of the triangle, please. And then while we're here, let's just go ahead and find sine, cosine, tangent of U and V. All right, quadrant 3, the only trig ratio out of the original 3 ratios that's positive is tangent. So I know sine and cosine are going to be negative. Now, when we go to use our sum and difference formulas, these are the fractions we're going to plug in. So we don't do a hand trick. We don't know what U and V equal. So we're just use but we know what the sine, cosine, tangent of U and V are, and that's what we need. All right, so the first one that we're going to find, A, is the cosine of U plus V. All right, so we would just go straight to our identity sheet, write down the formula for cosine of U plus V. And then we've already figured out what all those things are. All right, so in the place of cosine of U, I'm going to put -24/25. And cosine of V, I'm going to put -4/5. All right, and then sine of U and sine of V. And then from here, it's just multiplying fractions and adding them together. They're going to have a common denominator, so that's awesome. So we would just multiply across the numerator and across the denominator. Right, and then that works out nicely, that we have a common denominator. Right, what will this reduce to? Good, 25 divides evenly into both, so the answer is 3/5. All right. Let's do a tangent one, because the tangent ones are always a little harder. So for B, we're going to find the tangent of u minus v. All right, so you guys go ahead, use your identity sheet, write down the identity, please. And then we're ready to fill in our fractions that we found a second ago. So I can get it all on one screen. There we go. So for tangent of u, we're going to put in 7/24. And tangent of v, we're going to put in 3/4. All right, so we're not going to subtract the fractions on the top. So just hold off. You could. It's just going to create more work for yourself. So hold off on the numerator. So let's just bring it down. And then in the denominator, let's go ahead and multiply those. So it's going to be 21 over 96. All right, now we're going to pretty much do the same thing we did earlier. We don't have to worry about radicals though, so that's nice. That we did earlier with our tangent, where we're going to get rid of the fraction in the fraction. So here we just multiplied by 3 because they both had the denominator of 3. But I got that 96 by multiplying 24 and 4. So obviously 24 goes evenly into 96, and so does 4. So what I can do is just multiply everything by 96, and that's going to take care of all of our fractions. I promise it will. So whatever denominator you end up with down here, multiply by it, and it will take care of every fraction. Now I put the calculators on your desk because, I mean, this isn't that hard to do without a calculator, but it's pretty easy to do with a calculator. So what you would do is, there's different things you can do. I know for sure if you do the numerator times 96 divided by the denominator, it will 100% give you the answer. So 7 times 96 divided by 24. It might work if you do 7 divided by 24 equals 96, but it might give you a decimal that way. So what y'all get? 28. So that just turns into 28, which is awesome because it's not a fraction, it's easy. All right, for 3/4, a lot of people for 3/4 like to just do 0.75 times 96, that's fine. Or you could do 3 times 96 divided by 4, whatever you want to do. What y'all get? 72. Good. So that's going to be a lot easier to subtract compared to 7/4 minus 3/4. All right, in our denominator, we can do this without a calculator. So distribute the 96. I know if I do 21 over 96 times 96, that's just 21. All right, so then I'll just subtract on my numerator, add in my denominator, and that is it. That is my answer. Any questions on that one? Okay, we are going to do one more, and it's cosecant. All right, do we have a rule for cosecant? No. So how are we going to figure this out? what's related to cosecant that we do have a rule for? Sine. So let's just find the sine of u minus v, and then do reciprocal. All right. So I'm going to write the formula for sine of u minus v. Then I'll go up here and plug in what sine of u, sine of v, cosine of u, cosine of v equal. So you guys go ahead and do that on your own. Okay, and then just multiply our fractions together. And it's nice because we do have a common denominator. These work out that way, that you will have a common denominator. All right, so that's what the sine of u minus v is. So then I automatically know that the cosecant of u minus v is the reciprocal of that. So that's your answer. All right, so what questions do you guys have? No questions? You're good? All right, so your assignment is out of the book today. Now 26 is going to be kind of a long problem because you have to do the sine, cosine, tangent, all of maybe 15 degrees, I think. So that one is kind of long. And then the 37 is from yesterday, so it is pretty quick. And then 41 through 46 are like this last example.